Hi, I'm Adam from FabLab El Paso, and in this short video, we're going to look at the design process used to create an assistive device for a friend who is having trouble opening water bottles. First, let's start by defining the problem. In this case, it was pretty straightforward. My friend had a hard time grasping a water bottle cap tightly enough to open it while twisting. I looked online for existing solutions and found a couple different techniques and a couple different designs already available. A few of them looked pretty cool, but I decided to try a design of my own. The next step is to identify the requirements. The first requirement, which is the most important, is that the device needs to be able to open a twist cap bottle. I want the device to work with different size caps, from about a 28mm cap that's on water bottles to about a 39mm cap that's on sports drinks. The last requirement is that I don't want this to be too big. I want it to be able to fit into a pocket, so about the size of a hand or a cell phone. Next, we can start brainstorming some ideas. I came up with 3 different ideas. One that's essentially a strap wrench, a linear squeezer, and a rotational squeezer. The strap wrench is a proven concept, but it does require a strap, which could be annoying or difficult to manipulate. The linear squeezer does provide something larger to grip onto, but it doesn't really help with the twisting aspect. But the rotational squeezer is mechanically simple. It provides a solid object to grip onto, and it has a leverage arm that can assist with the twist. So this is the idea I chose to run with. Now we're on to the testing and iterating part of the process. I'm going to start by making a couple sketches. I'm going to work out any problems that pop up, and then I'm going to take those sketches and transfer them into a CAD program, something like Fusion 360. I'll be able to troubleshoot and tweak more within the program, and eventually create a prototype utilizing 3D printing, which will only take a few hours. When the parts are finished printing, I'll be able to assemble and test in person. Taking any feedback from the testing, I can return to my CAD program, make changes, print, test, repeat. This iterative design process allows you to dial in your idea, and with the use of 3D printing, it can happen very rapidly. Once we end up with a design that is acceptable, we can look into alternative manufacturing options, or just be happy using the 3D printed device.
Oh, that was easy.